Okay, good morning. All right, so today's notes is going to be 1.6 about angle pair relationship. So today's goal or essential question will be learning to identify what are vertical angles and what are linear pairs. We're also going to identify what are called the complementary and supplementary angles. And so some of the vocabulary words we have here. And so the um, vertical angles are vertical angles that have two angles whose sides form two pairs of opposite rays. Now, that may be a little difficult to understand. An easier way to kind of think about vertical angles is if two lines intersect or two segments intersect like this, then the vertical angles are angles that are on the opposite corner, right? Opposite end. So they're not next to each other, they're not adjacent to each other, but they're opposite corner of each other. So they're what's called vertical angles. So that's probably an easier way of thinking about that. So if you look at this picture here, so 1 and 3 are vertical angles, angle 1 and angle 3. And notice I marked with one arc here and one arc here, which means that they're also congruent. So whenever you have two straight lines or segments intersecting like that, vertical angles are angles on the opposite corner, and they will always be congruent. And so same thing with angle 2 and 4. Notice I put two arcs here and two arcs there. So those are vertical angles, and they're also congruent to each other, right? Linear pair are just kind of like how it sounds. They're a pair of angles that are next to each other that form a line. That's why they call linear pair, right? So linear pair consists of two adjacent angles, which means they're next to each other, right? Whose non-common sides are opposite rays, which means that if you look at angle 1 and 2, right, they're next to each other, they're adjacent, and the non-common sides, so this is the common ray in the middle. Non-common sides are these two rays here, and they form opposite rays or form straight line. Remember, opposite rays form a line, right? So linear pair are two pairs that are next to each other, adjacent, and they form a line or opposite rays together, right? So same thing with 2 and 3 are linear pairs, 3 and 4 are linear pairs, and 1 and 4 are also linear pairs. And it might be kind of obvious, but linear pairs together are 180 degrees together, right? And so they're also what's called the supplementary angles. We kind of talked about that a little bit. Supplementary angles are two angles that add up to 180 degrees together. Now, I drew a picture here where the two angles are adjacent or next to each other, but that does not necessarily have to be, right? Supplementary angles are any two angles, not necessarily next to each other, as long as the two measurements add up to 180 degrees, right? Complementary angles are similar to supplementary angles. They add up to 90 degrees. So I drew a picture here. So that's a right angle there. And the two angles that are next to each other in this case, but again, they don't necessarily have to be next to each other. They just have to add up to 90 degrees, right? So complementary adds up to 90, supplementary adds up to 180 degrees, right? So sometimes you'll just see complementary angles, or sometimes you'll just call that complement, or same thing here. Sometimes you call that supplementary angles, or sometimes you'll just see supplement, right? So they kind of use interchangeably, whether you use complementary angles or complement, or supplementary angles or supplement. Just know that the complement adds up to 90, supplementary angles add up to 180 degrees, right? So we're going to take a look at some of those vocabulary words and look at some examples, right? So here's an example of a flag. And so you have these two lines on the flag that are intersecting here. So I know it's kind of thick, but think of these two, I guess, those shapes as just a line intersecting like that. And so angle 1 is this corner on the left, and angle 3 is the other opposite corner, which is the vertical angles. And then angle 2 is the angle on the top, and then obviously angle 4 is the angle at the bottom. So angle 2 and 4 are vertical angles, angle 1 and 3 are vertical angles that are congruent, right? So if you look at the picture, angle 1 has measure of 60 degrees. So here, that's 60 degrees on the angle on the left side. So with that in mind, we should be able to find the measurement of angle 2 and measurement of angle 3. So measurement of angle 3 is easy because that's also 60 degrees because they're vertical angles, right? So measurement of angle 1 is equal to measurement of angle 3, and they're both equal to 60 degrees, right? Because they're what's called the vertical angles. So when two lines intersect, opposite corners are always called vertical angles, and they're congruent, right? You could also say angle 1 is congruent to angle 3 because of that they are vertical angles, right? Vertical angles are always congruent, right? Now, measurement of angle 2 is linear pair, which means that measurement of angle 1, right, plus the measurement of angle 2 is going to equal to 180 degrees, right? They're supplementary angles. They add up to 180 degrees because together they form a straight line. So that's called the linear pair, right? Well, so measurement of angle 1 is 60 degrees, and measurement of angle 2 is what we're trying to find. So then we subtract 60 on both sides to cancel that out. So that will give us the measurement of angle 2 as 120 degrees, right? So then, 120 degrees plus 60 degrees together, so that's 120 degrees. So 120 degrees plus 60 degrees together form 180 degrees, which is a straight line there. Same thing on the other side, right? 120 degrees plus 60 degrees together, they add up to 180 degrees, which is what a straight line, straight angle is, right? So those two are supplementary, right? Because they're called linear pair. So this is because of what's called the linear pair, and linear pair always adds up to 180 degrees, right? Because a straight line, is also straight angle, which is 180 degrees, right? So those are some of the vocabulary words about vertical angles being congruent and linear pair adding up to 180 degrees, right? All right, so let's look at another example using either vertical angles or linear pair. You can use either one, whichever is easier, depending on what variable you're trying to solve, right? So we're trying to solve for x and y, right? Using the idea that the linear pair is 180 degrees. So if you look at this, this one has x here, and then this one has x there. So we're going to use linear pair because if I add these two angles, right, they're going to add up to 180 degrees. So that's what I'm going to do to solve for x. So I'm going to add 2x plus 5 plus the other angle at the bottom, which is 4x minus 5. And so if I add these two angles, they are what's called a linear pair again, right? Because together they form a straight angle. So they're going to add up to 180 degrees, right? So then you solve this for x by combining like terms. Now in this case, we can add the 2x and 4x because they're together on the same side of the equal sign. So you just have to add them together as they are. So 2x and 4x is 6x. And then same thing with 5 and negative 5. If I add 5 with negative 5, or 5 minus 5, well, that's just 0. So they cancel each other out. So this, you don't even have to write because it's 0. And then on the other side, you just copy 180 degrees. And then you divide by 6 to cancel this out. And so that's just 1x or x, and that's going to equal to 30. So x is going to equal to 30, and we plug it in to find the angle measure just like we did before. So we plug it into here, and you plug it into here. So then when we do that, this is going to be 2 times 30, which is 60, plus 5. So that's going to be 65 degrees, right? And then you plug it in here. So that's 4 times 30. So we do 4 times 30 minus 5. 4 times 30 is 120 minus 5. So that's going to be 115 degrees there. So we know that 65 degrees and 115 degrees together, they form 180 degrees. So that's correct because that's the linear pair, right? So that's how you find the x and the angle measurements by plugging it back in using the idea that linear pair, when you add the two angles together, that's going to equal to 180 degrees. Same thing on the other one with the y here. So we add the 7y, right? 7y minus 25 plus the other angle, which is 3y plus 5. And that's also going to equal to 180 degrees. Again, that's the linear pair on the other side. So again, the 7y and 3y is on the same side of the equal sign. So you just add that. So that'll be 10y. 7 plus 3 is 10. And then negative 25 and positive 5. So you subtract, right? 25 minus 5, which is 20. But since you have more negative numbers, so it's going to be negative 20, right? So then this is negative 20. So you add 20 to cancel that out. So you add 20 to the other side. So then you're left with 10y is equal to 200. And you divide by 10 to get rid of the 10 there, and then divide by 10. So 200 divided by 10 is 20. So y is going to be 20 in this case. So then you plug it in here and here again to solve for those two angles. So that's 7 times 20 minus 25. So that's going to be 140 minus 25. And then that's 140 minus 25 is 115 degrees, right? And then the other side, you plug in 20 there. So 3 times 20 is 60 plus 5. So that's going to be 65 degrees, right? Now, I don't know if you noticed something here. There's actually a little typo or mistake on this picture. Because if you look at it, right, we got vertical angles here, the opposite corners being different, right? So this is 65. Now down here should be 65. So we have a typo or mistake where one of these should be switched. Either the y should have been switched or the x should have been switched here. So the 3y plus 5 should have been at the bottom. And then the 7y minus 25 should have been on the top, right? That way, the whole picture makes sense, not just the x's and the y's, right? So there was a little typo there. I just wanted to point that out because if you look at the whole picture, that does not look good, right? Because the vertical angles should be congruent as well. Not only the linear pair adds up to 180 degrees. So this one was focusing on linear pair, but then the vertical angles should have been still congruent and same measures. But so there's a typo here. Just wanted to point that out that the y's or the x, one of those should have been switched. That way, everything works out fine. But we'll just leave it at that for now because we're using the linear pair in this case to figure out the x and the y. Okay. All right. The next one. So again, we're looking at it one more time on the checkpoint using the vertical angles or linear pair. You can use either one, and they should all kind of match, except for a typo, a little mistake on the previous example. So here we know the measure of angle 2 is 52 degrees. So this angle is 52 degrees, which means that angle 4 is also 52 degrees because they're vertical angles, right? So that should have been easy. And then using the 52 degrees, we can figure out either 1 or 3, and then they should be congruent. So I might as well just put the arcs here. So the two arcs for 1 and 3 are congruent. One arc for angle 2 and 4 are congruent. So then to figure out the measurement of angle 1, all we have to do is subtract 180 minus 52, because that's linear pair, right? So you can just do 180 minus 52, which is going to be 8, because we have to borrow from the 7, so that's 10, right? And so that's going to be 2 and 1. So this is going to be 128 degrees, which adds up to 180. And then the opposite corner, which is the vertical angles, is going to be congruent. So that's also going to be 128 degrees. Okay? So that's vertical angles are congruent, and linear pair adds up to 180 degrees. All right, so this is similar to example 2 that we just did. So hopefully this one will come out all right, but let's use the linear pair for the x right here. So we got the 6x here and then the other 6x there. So we're going to add those two. So we're going to add 6x minus 6 plus the other linear pair there, which is 6x plus 6. And that's always going to add up to 180 degrees because they're a linear pair, which means together they form a straight angle. So then you combine 6 and 6x, which is 12x. And the negative 6 and positive 6 cancels out to 0, right? And so that's going to equal to 180 degrees, and then divide by 12 to cancel that out. Divide by 12. So x is going to equal to 15, right? So again, if that was hard to do, mental math, you can plug that in your calculator, right? So x is equal to 15, and then you plug it back in here to solve for each angle measurement, right? So not only you have to find x and y, which we did, right? You have to plug it back in and find the measurement of each angle. So plug in 15 here, so that will be 6 times 15, which is 90 minus 6. So that's 90 minus 6, which is 84 degrees, right? So then hopefully later we'll get 84 degrees on the vertical angles on the opposite corner if they put that correctly without the mistake. But let's figure out the other one here on the top. So that's 6 times 15. So that's 6 times x, which is 6 times 15, which is 90 again, plus 6. So that's going to be 90 plus 6, which is 96 degrees, right? So again, 96 and 84 adds up to 180 degrees, which is the linear pair. They're supplementary because they add up to 180 degrees, right? That's how you figure out the x using those two linear pair. Now we're going to do the same thing, figuring out the y with these two at the bottom, right? So we're going to add the 9y minus 3 with the 8y minus 4. So let me see if I can squeeze that in here. So if I do 9y minus 3 plus 8y minus 4, and again, that's going to also add up to equal to 180 degrees because that's linear pair at the bottom. So then you add the 9 and 8, so that's 17y. And then this is both negative 3 and negative 4. So since they're both negative, you add them. So that's 7, but it's going to be negative because it's going to be like losing 3 yards and losing 4 yards on the third down. So together, you lost 7 yards, right? Or lost $3, lost $4, so you lost $7. That's going to equal to 180 degrees, and then you add 7, right? because that's the opposite of subtracting 7. So then you get 17y is equal to 187, and then divide by 17 to cancel that out. Divide by 17, and that should equal to 11. So y is equal to 11. Again, if you can't do that in your head, mental math, then just divide that with the calculator, right? And you should get 11. So then when I plug in 11 here, that's going to be 9 times 11, which is 99, minus 3. So 99 minus 3 is going to be 96 degrees. So this one worked out good, right? Because the opposite corner, the vertical angles on the top was 96 degrees. This was 96 degrees. So this one, they all match. So this one should be 84 degrees. Let's see. So that's 8 times 11, which is 88, minus 4, right? 88 minus 4 is indeed 84 degrees. So everything works out in this case, right? So the linear pair is all 180 degrees, whether you look at it on the left or the right or top or the bottom, right? They should all add up to 180 degrees. And the opposite corners, which is called the vertical angles, are same. So that's 84 and 84, and then 96 and 96. So they all kind of work in this case, even though there was a mistake on the example 2. Right? So that's how you use the linear pair or vertical angles to solve for the x and the y. Okay? All right, next one. So then here, we're looking at the idea of complementary and supplementary, right? To look at a clock here, right? So again, complementary, if you remember, right, they add up to 90 degrees. And supplementary, if you remember, adds up to 180 degrees, right? So complementary angles together, if you were to kind of put it next to each other, adjacent angles, if you put them together, should form a right angle. Supplementary angles, if you put them together, adjacent next to each other, they should give you a straight line or a straight angle, right? So if you look at the two clocks here, right, you know the full circle is 360 degrees, right? And since there are 12 hours on the clock, if you think about each hour is going to be 360 degrees divided by 12 hours on the clock. So each hour is going to be about 30 degrees, right? So that's how you figure out what each hour the angle would be. So, I mean, we can certainly measure this with the protractor, but you can also figure out using algebra, because the full circle is 180 degrees. And then since there are 12 hours, you divide. So that means each hour is 30 degrees. So here, the 11 o'clock is 30 degrees, right? Because that's just the 1 hour difference, right? From 11 to 12. The difference between the hour hand and the minute hand is just the difference for 1 hour, right? So from here to here is traveling 1 hour on the clock, around the clock. So that's 30 degrees. Now, 2 o'clock, from the minute hand to the hour hand, you're traveling 2 hours if you were to travel from here to here. So that would be 60 degrees, right? Because each hour is 30, so 30 times 2, so that's going to be 60 degrees, right? And so if you add 30 plus 60, that's going to add up to 90 degrees. So therefore, these angles are what's called the complementary, right? So they're complementary angles together, and they're complementary of each other, right? Because they add up to 90 degrees. So that's how you can kind of use the clock to think about whether the two angles that the clock shows are complementary or supplementary. So again, here is 30 degrees, here is 60 degrees. So 30 degrees plus 60 degrees is 90 degrees. So these two angles are what we call complementary angles, because they add up to 90 degrees. Now, even though they're not next to each other, that's okay, right? They could be next to each other. If you were to put this together, they would form actually a right angle, right? Because that's 90 degrees. All right. So just know that each hour on the clock is 30 degrees. That's an important information to remember. And we figured that out by doing 360 degrees for the whole circle divided by 12 hours on the clock. All right. Okay, next one. So this one is just, again, using the idea of complementary and supplementary. And we could also call that what's called the complement, which is adding up to 90 degrees, and supplement, which is adding up to 180 degrees. So complement is 90 degrees, supplement is 180 degrees together, right? So here, we're given that the two angles are complement, which means that these two add up to 90, right? So if the measurement of angle S is 32, the measurement of angle T is going to be 90 minus 32, right? So 90 minus 32, well, initially, actually here, we could put measurement of angle S, right? Because that's what the measurement of angle T will be, because they're complement. So it's going to be 90 minus the other angle, which we know is 32. So that is going to be 58 degrees, right? So 58 and 32 adds up to 90, okay? The other one is supplement, which means 180 degrees. So the measurement of angle V will be 180 minus the measurement of angle U, which is given to us as 27 degrees. So it's 180 minus 27, which is going to be 153. Excuse me. So that's 153 degrees plus 27. So that adds up to 180 degrees, right? So that's what we call supplement or supplementary angles, right? All right, so next one. So again, we're going over the examples of what we just talked about, right? So here, we're determining whether the angles formed here and here are complementary, which means they add up to 90 degrees, or supplementary, which is 180 degrees, or neither or neither, which is, if it's not 90 or if it's not 180, then it's going to be neither, right? So if you look at this, if you're moving from 8 o'clock to 12 o'clock, right, the hour hand and the minute hand, that's 4-hour difference, right? So 4 times 30, because remember each hour is 30 degrees, so 4 times 30, that's 120 degrees. So this is going to be 120 degrees. We get that by 4 times 30, right? Now, same thing here. That's another 4-hour difference. So that's also 4 times 30, 30 degrees for each hour. So that's also 120 degrees. So they're congruent, right? Because they're both 120 degrees, because they're both 4 hours apart from the hour hand to the minute hand. But they're not complementary, obviously, because that's 120, 120. And they're not supplementary, because 120 plus 120 is 240. So then it is neither or neither, right? Now here, from 7 o'clock to 12 o'clock, that's a 5-hour difference, right? If you're to move from here to here, you're moving 5 hours to get to here. So that's 5 times 30 for each hour is 30 degrees. So that's 150 degrees, right? Now, that's only 1 hour here, right? So that's 30 degrees here, because each hour is 30 degrees on the clock, remember? It's 360 divided by 12, which is 30 degrees for each hour. So then this one, when you add 150 plus 30, that's equal to 180 degrees, which means that these two angles are what's called a supplementary. So supplementary adds up to 180, complementary adds up to 90. If it does not, then you say neither. Okay. Number 5, we're finding the complement, right? Because it says complement, M and N are complement. So we know the measurement of angle M is 63 degrees. So the measurement of angle N measurement of angle N is going to be 90 minus 63 because it's complement, right? Complement adds up to 90. So you just subtract 90 minus the other one. And so that should give you 27 degrees. So 27 plus 63 is going to add up to 90, right? So one angle is 63, the other angle is 27. Together, they add up to 90 degrees. And then the other one is supplement, which means 180 degrees. So then if I know one of the angle, the other angle, so the measurement of angle D is going to be 180 minus 109, because together they have to add up to 180. So if I subtract 180 minus 109, that's going to be 71 degrees. So again, 71 plus 109 is going to give you 180 degrees, which is what we mean by supplement. So supplementary angles add up to 180 degrees. Complementary angles add up to 90 degrees. So make sure you don't confuse those two. All right. So that's how we figure out complementary or supplementary angles. All right. Okay, so that was all the notes. So make sure you do the summary and then look over the notes and do the highlight and come up with questions or comments that you want to ask me during the class time. So that way we can discuss more in detail. Okay. All right. Thank you.